Hello everyone, welcome back to my channel. Today let's review an easy question that I solved around 4 months ago. So I know I uploaded the number 2 version of this problem a couple weeks ago, but I didn't do number 1, so let's go over it. So you're given a zero indexed integer array, and essentially you just want to find triplets where the first index is less than the second, and the second index is less than the third, triplets, and where the first element is less than the second and the third element is less than the second. So the second is the biggest out of the three. So let's go ahead and iterate over nums from left to right. Because this is an easy question, we can just use brute force. I plus 1, length of nums. I know that in my number 2 video, I use a sorted list, but we're not going to do that in this one. Because the goal of my channel is just to make things as intuitive as possible as long as it passes the question. So if nums of I is less than nums of j, which is also bigger than nums of k, then we want to find the minimum sum of the mountain triplet. So nothing can be bigger than float of infinity. So if we find a valid triplet, then update result to be the sum of the triplet, which is nums of I plus nums of j plus nums of k. And at the end, if result is equal to float of infinity, then there was no triplet that was ever valid, so return -1 as it says here. Otherwise, we can just return the final result that we get. So let's submit this, and it does pass all test cases, but it's not the most efficient because, again, I did come up with this on the fly by myself in like 2 minutes. So there's a better way to do this, which is using a sorted list. And I can show that to you. So basically, we want to have a lefts and a rights list, just like with the number 2 version, which I did a couple weeks ago. So I'm going to try to remember how I did that. So now let's call current is nums of I, and we're going to remove the current element. Yes, remove the current, and then add the current to lefts because left starts as empty. So if lefts and rights, let's print lefts, cur, and rights. So in this case, right, to find a triplet where this is the biggest one, basically we are going to say if there is an element here which is less than here, then we can find that. So let's do a bisect left. So bisect left inside of lefts cur, and bisect right instead of rights current. And this is just going to give us the place that we want to, so everything before 0. So LL is lefts of everything up to left. Rights is going to be rights of right to the end. Print LL and RR. So now what this does is shows you let's do bisect left. So now the current element is, so I guess we can also just make this simpler. So if lefts and rights, then for L and lefts, if L is, well, we just want to find how many elements in the left list are less than or are bigger than the current. Or sorry, are less than the current. So that's why we did the bisect left. Inside of lefts with current, let's print lefts up to L. And then right, I think I wrote it incorrectly, bisect right of rights inside of current, print rights of right to the end. So LL equals to lefts. To left, it's supposed to be lefts, not current. RR is going to be rights of R to the end. Let's print LL and RR. Okay, so +1. So this is now good because this guy has to be the biggest. Is it right +1 to the end, I think? How is this guy going to be the biggest? Yeah, this is a bit of a hassle, so I'm just going to cut this video short because the way we did it with the sorted list is a bit overcomplicated. Just go with whatever we had originally because I don't want to overcomplicate this as an easy question. Range I +1, length of noms. Okay, in range j +1, length of noms. If noms of I is less than noms of j, which is the noms of k, minimum of result of the triplet sum. Result is flow of infinity. Return -1, else return result. So there you go. That's going to be it for this video. Just keep it simple. If you want to see a sorted list solution, please let me know. I would use a similar approach as with the second problem that I did. It did take me a while to come up with, so let me know if you'd like to see that. Other than that, thank you for watching and stay tuned for more.